And it would have gone pro if it wasn't for my bum basalt eruptions. Where we're at right now, we're trying to figure out why we can't see the Klamath Blue Mountain Lineament, or KBML. The long story you didn't watch this video is it's the Columbia River flood basalts' fault. Way back in video 8, we talked about the sheer size, the scale of how big these overall eruptions were and their effect on the Olympic Wallowa Lineament, or OWL, in Washington. What was it, like 600,000 CenturyLink or Lumen Fields in Seattle? Another way of comparing it that you may be able to reference: Columbia River flood basalts, 210,000 cubic kilometers. The entirety of Earth's lakes combined is 199,000 cubic kilometers. Estimated, of course. Need I say more? But once again, we're trying to find KBML. And to put it quite simply, in Oregon, it's beneath all of that. Once again, very hard sell, but let's get into it. Recall in the sand experiment that we did in the last video, where the balloon rose up out of the sand and kind of created this upward pressure that had cracks around the size of it, and then when it went back down, it created a hole. The Columbia River flood basalts are a result of this kind of cracking that occurred from the rise of the Yellowstone hotspot. And because of the cracks that were coming from the rising of this, we get the dike swarms that cause the basalts all over the place. Well, this is in the Tiana way, as it serves the same purpose. Really and truly, all a dike is just an area where there were cracks or weakened rock, where molten material came up, forced its way into the space between it, and was able to erupt. And since these bodies are also have the word dike swarm next to them, swarm is a pretty self-explanatory word, there's a lot of them. And it's not just like a little area. These dikes on average are anywhere from 300 to 3,000 feet long by 10 to 40 feet wide and expand over an area of about 200 miles by 60. And that's just the biggest one in the Chief Joseph alone. With relation to Oregon, though, they get all three of the main phases of dike swarms. You've got the Steens dikes, the Monument dikes, and the biggest of all, Chief Joseph. Now, in terms of the erupted material, this is even more fascinating. By and far, the vast majority of these flows come from the Grand Ronde basalts, which I've seen anywhere from 70 to 90% of the overall mass is that. And they primarily extend from those Chief Joseph dikes. But the real interesting part here is that those flows were only between 17 million and 15.4 million years ago. That's really quick. The Steens basalts were the first volley from this, and notice how close they are to where the Yellowstone hotspot got its start. Now compare all of this to where the estimated area of KBML is. But what's going on with OWL? How come we can't see KBML, but OWL is so well expressed in Washington? Well, recall from the Blue Mountains video that they're pretty young. As that material was being erupted in the general area of the Blue Mountains, that density changed underneath of that body and caused the bottom part of the blues to drop off and sink down into the mantle. Doing so left the rest of it able to spring out. This rapid rise occurred between 12 to 10 million years ago, which, mind you, is after the vast majority of those basalts were erupted. So to geologists, it was very strange to have rock that old, that far inland, that wasn't from around here. It's exotic. And more geologists discovered that the Klamaths and the Blue Mountains had similar geology and combined them together. But here's where we get into the really nitty-gritty of this. We have to talk about magnetism. In the right circumstances, volcanic material, when erupted, can measure or determine which direction the poles of our planet are facing. It comes down to the complicated chemistry and the atomic makeup of the rock, which I'm not going to get into for you. Shown in black to my right is normal polarity, or what our magnets today show, versus white, which is reverse polarity. So think north is south, south is north. Nonetheless, we have the data on this. But to dive just a little deeper, remember that the Blue Mountains and the whole lineament is facing southeast to northeast. But magnets are north-south or south-north. Oh, this does something really interesting. Given the fact that we know that KBLM is southwest to northeast, but the poles are north to south or south to north, we have to get them north to south somehow, so we rotate them back in a counterclockwise fashion. And paired with the GPS clockwise rotation that we've talked about a little bit as a part of this story, this helps give credence to that whole motion of the Northwest. Look at it like this. KBML is right here. You see all those directional arrows that are headed off in that? Move KBML back, and look, we're north-south, or south-north. But there's one more thing. The metaphorical mic drop, if you will, gravity. But don't think of measuring gravity as like measuring a jump. Think of it more as measuring density. Not everywhere on our planet has the same pull or the same effect. Think of the crust almost kind of like a bed. Say you put a basketball underneath of your bed and a feather at the other end. Those would feel very different. Geologists use this method of sorts to measure for different areas. For example, like basalt is a lot more dense, more gravity, than somewhere like a sedimentary basin, a lot less gravity or density. So using that across the state of Oregon, geologists found we can very clearly see that there is a difference in gravity between the southeastern part of the state and the northeastern part of Oregon and South Washington. What's going on here? So we figured out two things today. One, basalt buried KBML, and the magnetic signature helps us determine the clockwise rotation of the Northwest. And two, fancy gravity density measurements have helped see a pretty straight line underneath of all of that basalt. So we have our evidence for KBML and OWL. We know roughly where it is, and we know the geology around it. It's now time to start unpacking and answer what it might be. But to do that, we have to go back to the start. In our next video, we head back to the Crescent Basalts, the Olympics, Silencia, which for now on will be known as OCS.